Hello, welcome for joining us. Another Safer Sim webinar this afternoon. Today we have Dr. Shannon Roberts from the University of Massachusetts, and I'll hand it off to you.
Thank you, Dawn. I'm going to share my screen. All right. So today I am going to be talking about attention and adaptation of teen drivers to driving automation systems. This is a collaborative project. There's myself, I'm Shannon Roberts, an associate professor in industrial engineering. I study human factors of transportation systems. The co-PI on this project is Jennifer McDermott. She's an associate professor of psychology, also at UMass, and her research focuses on attention skills of children, and she has a particular interest in looking at ADHD within teens. So, I know in a lot of presentations, people wait to give you the really interesting things at the very end. So I'm going to tell you right now what the main takeaway is. And that is, as teen drivers are exposed more to driving automation systems, there's a potential for enhanced trust, higher acceptance, improved behavioral adaptation, as well as accurate mental models. But it's only for certain groups of drivers who are receiving these benefits with increased exposure to driving automation. So that's the main takeaway. You'll see how I came to that conclusion after I finish the presentation today. So as I said, it was myself as well as Jen McDermott. However, for the presentation today, I'm going to focus on the study that we did in the driving simulator. As a bit of background, we know that there have been a lot of past studies on driving automation systems, and they show really positive results when it comes to preventing crashes and improving driver safety. We also know that in general, advanced driving assistance systems really do have the potential to improve safety for teenage drivers. We know that teenage drivers are at increased risk of crashing. They are very likely to get citations and warnings. At the same time, this technology can really reduce their crash risk. When we look at all of those studies that show the great benefits of advanced driving assistance systems, the participants are adults. They're usually people with a decent amount of driving experience, definitely 18 and above, usually mid-20s and above. And we see that a good chunk of these studies tend to focus on people's behavior at one point in time. So with that said, the goal of this study was to look at driver behavior over an extended period of time, 4 weeks, and we specifically focused on teens using advanced driving assistance systems, in particular, a level 2 driving automation system. So again, the goal was, we're focusing here on teen drivers, and we want to see how their behavior changes over a 4-week time span as their exposure to a level 2 system changes in that time span. Again, this is the focus of the study that we did in the driving simulator laboratory. My collaborator, Jen McDermott, also did quite a few studies in her learning laboratory that was really focused on attention skills for these teenage drivers. One of the things we want to do in the future is connect this driving behavior data to her attention skills data to see the relationship between those two things. However, today we're just going to be focused on the driver behavior data. So what we did was we had 20 teen drivers come to UMass to do this experiment. And on average, they were about 16 and 0.7 years. So in Massachusetts in particular, you cannot get your junior operator's license until you're 16 and a half. And so when you're looking at the average age of our participants, they basically had only been driving for a few months by the time they did our experiment. Across the 20 teen drivers that we had 8 females, 11 males, and we had 1 individual who was non-conforming. The 20 teen drivers visited our driving simulator lab once a week for 4 weeks. So again, this was the piece that really speaks to how behavior changes over time. We measure their performance once a week for 4 weeks straight. Here you can see a picture of the UMass driving simulator. It's a full cab surrounded, in this picture you can only see 5 of the screens, but where the picture is taken from, there's an additional screen. And so it really gives you just about a 330-degree field of view. Every time the teens came in to drive the simulator, they experienced level 2 automation. And in half of the cases, they experienced a scenario in which the automation could not handle the roadway environment and it required a takeover. And the other half of the scenarios, level 2 automation could for sure handle the situation on the road, and it did not require a takeover. So here are just a few examples of some of those scenarios that we exposed the teen drivers to that required a takeover. The first one on the left, we had the teen drivers in an urban environment, and they approached a pedestrian in a mid-block crosswalk. This required a takeover in order to let the pedestrian cross the road. Another Massachusetts-specific thing that I should mention, in Massachusetts, it is a state law to stop to let every single pedestrian cross the road. The second example scenario was a merge. And so the teen driver was driving down in a rural area with trees surrounding the roadway. And their direction of travel had 2 lanes and it merged into 1. The third example scenario, the teen driver was in an urban environment. It was a 1-lane in their direction of travel. And as they went around the bend of a curve, they approached a truck that was jutting into their lane. And there were 2 orange cones signifying that the truck was stopped on the side of the road. So again, in all 3 of these situations, the teen driver would have to take over. These are just some examples of the situations they saw. And again, there were just as many scenarios that they were exposed to where they did not have to take over. And the purpose of providing these different types of scenarios was to see how did they react to these different situations. We didn't just want to show them edge cases in which the level 2 system could not handle the scenario. We also wanted to show them situations where the automation would perform perfectly fine. For this presentation, we really focused on measuring driver behavior through surveys, which of course focus on subjective measurements of driver behavior. In particular, we measured these teen drivers' trust, acceptance, adaptation, and mental models of this level 2 system that they were exposed to. So trust is the driver's belief that the system would respond appropriately. Acceptance is, as the name suggests, whether they accept and intend to use this level 2 system. Adaptation really speaks to looking at changes in driver behavior and changes in attitude as they are exposed more and more to this system. It also looks at how reliant they are on the technology. And last, mental models is, or the definition of mental models rather, is the structure that reflects how someone understands the system and its functionality. So with each one of these 4 surveys, they were delivered to the teen drivers at the conclusion of every experiment that was again spaced 1 week apart across 4 weeks. The addition is that for mental models, we also assessed that at the very beginning of the experiment before teens were exposed to the simulator. So we actually have 5 data points for mental models, and we have 4 data points for the other 3 surveys. So now I want to jump into just some of the results, because the results for this experiment were actually quite a bit, as you can imagine. When we have 20 people coming into the lab 4 times, we collect quite a bit of data. I mean, here you can only see I'm focused on the survey data. We also collected driving behavior data. And again, we also have data on their attention skills. So I'm just going to focus on the survey data here. One of the things we focused on was of course, how time is impacting their driver behavior. And we saw, interestingly, that when you expose these teens to level 2 automation within a 4-week time span, it doesn't have an impact on as many things as we thought. Mainly what we saw was that as time went on, it was affecting the teen drivers' mental models of the actual L2 system. So in particular, as time went on, they had a greater and essentially a more correct understanding of their role as a driver when they were using the L2 system. So in particular, we asked them what their responsibility was when using this system. And as time went on, we saw more correct answers. And the driver's role when using this system is to make sure that they pay attention and that they're monitoring the roadway and the system to make sure they're ready for a takeover at any given time. Another thing we saw was that as time went on, their expectation of how responsive the system would be to different events was quite variable. It went down and then it went back up. So here what we're suspecting is that as we expose them to some situations where the automation behaved perfectly fine and some situations that are edge cases that the automation did not know how to respond to, we're seeing that that does have an effect on their expectations of how the system functions. So again, it fluctuated over time. There was a dip in the middle and then it went back up towards the end. Now, as I said, time only impacted mental models. We didn't see an effect of time for trust or acceptance. And what we are postulating here is that there isn't a strong effect of time because we have essentially brand new teenage drivers. They have not been driving with their license for a very long amount of time. And so even though we expose them to this system over a month, they probably need an enhanced exposure over months, plural, for them to really get a better understanding of the system and for it to really affect their trust and acceptance. We saw, maybe more interestingly, that gender had an impact on quite a few of our measurements. So we saw that gender impacted mental models, acceptance, as well as adaptation. We saw that females were more likely than males to correctly understand their role when using this system. So they knew that they were responsible for monitoring the system and being able to take over at any given time. Interestingly, the non-conforming individual preferred to be even more vigilant, and they repeatedly said over a 4-week time span, when using this system, I want to keep my hands on the wheel and my feet on the pedals. Another significant effect that we saw here was that both males and the non-conforming individual in general have a higher acceptance of the system. They see more benefits of using a level 2 system, and they are more likely to use it regularly in comparison to females. So a lot of research has shown that, of course, there are gender differences in driving behavior. And what was more interesting here was that gender differences show up really early, right? We have brand new drivers who are 16, and we have females who have a really good understanding of their role. And then we have males who seem to simply like using technology and plan to use it on a more regular basis. The third interesting effect that we saw was crash history. In particular, a teen's crash history impacted their mental models as well as their adaptation. So teens who had been in a crash were more likely to know how level 2 sensors operate in terms of which parts of the car they monitor and essentially where the sensors are. So we had a question on our mental model survey that essentially asked, when you think about the different sides of your car, front, back, and sides, where does the automation monitor to see if it should brake, accelerate, or steer? Those who have been in a crash were more likely to select the correct answer and say level 2 systems are focused on what's happening with the car in front. Additionally, those who have been in a crash were, in general, less likely to use a level 2 system, and they were much less likely to say they would use a level 2 system if they were impaired or distracted. Now, this finding is expected, and it definitely aligns with the literature in the sense that once a teen gets into a crash, which is definitely a significant event, because these teens must have been crashing when they had their permit, right? Because they just got their license. It has a significant impact on how they drive later on. It has a significant impact on basically whether they trust technology, and it has a significant impact on their understanding of how technology functions. So it's unfortunate that a crash leads to these positive behavior changes that are really accurate, but we do see that those who basically have more experience with how cars work have a greater understanding of this technology. And the last interesting result that I want to highlight is how teens' exposure to advanced driving assistance systems, how that impacts their performance and their understanding. In particular, we saw that teens who had any sort of advanced driving assistance system in their personal vehicle, that definitely improved their mental models of how a level 2 system might function. In particular, they were more likely to understand what their role was as a driver when using this system. They had lower expectations of whether or not the system would be responsive to roadway events. However, they were more likely to use the system if they were impaired or distracted in some way. So basically what we're seeing is that if a teen has something like blind spot monitoring, adaptive cruise control, or lane keeping assist in the vehicle that they use on a regular basis, naturally, they have a better understanding of how technology functions, right? They have an improved mental model. However, it also makes them a little bit over-reliant on technology because these were also the teens who are more likely to say, we think it's okay to use this technology if I'm distracted or impaired. Now, here I've only highlighted 4 of the interesting results that we've seen. We also saw impacts of things like cell phone usage, race and ethnicity, exactly how many months they had their license. We saw impacts of those things on these survey responses as well. But in this presentation, I only wanted to highlight some of the more interesting results that we found. So I'm going to close again with that main takeaway, which is as teen drivers' exposure to driving automation systems increases over time, there's a potential for enhanced trust, higher acceptance, improved behavioral adaptation, as well as accurate mental models. But we only see these benefits for certain groups of drivers. Okay, so now I can take questions or comments.
Thank you very much. Attendees, everyone who's here, you should be able to unmute yourself if you have a question or comment. You are also welcome to type it in the chat if your background's noisy, and I'll read it out for you. Giving someone a chance to type. I don't see anybody unmuting themselves. Well, I will ask you a question in the meantime. I found this very interesting and encouraging. I wonder if you, while you're doing this, 4 weeks for a month is a long time when you're learning how to drive. So could you remind me, where were they just after getting their license, or was there a wide range of that?
Most of these teens had just gotten their license when they did our experiment. I should mention, though, again, this Massachusetts specific thing. In order to get your license when you're under 18, you have to go through driver's education.
Mm.
Most teens do driver's education when they are 15 and a half. Then they get their permit at 16. That's
Okay.
when they actually start driving. And then they get their license, which has fewer restrictions than the permit, of course,
Mhm.
at 16 and a half.
Okay.
So yeah, hopefully that helps give context for where these teens are in the driving process.
It helps me because Iowa, you can get your learner's permit where I am at 14. If you take driver's ed, you can get a school permit at 14 and a half, and you can get a graduated license at 16 and then a full license later. And so every state is a little bit different, but it does give a little context. I think that was part of my question is that 4 weeks is a long time when you're really learning. It's not so long later. Even though we know teen drivers are learning and getting safer for years, if it's right after licensure, they're still really new, and that's a really long time in their timescape and in their learning process.
Yes, yes, I totally agree. But I think you bring up a good point that since they are just learning at this time frame, there's tons of compounding effects of they're just not very good at driving a car at this point.
Yeah. Yeah.
And then we're adding on this extra piece of we also want you to drive this car that has technology
Mhm.
that can potentially help you be a better driver. And we're also measuring, how well you're learning about the technology at the same time.
Yeah, it's a lot. It's a lot. And at the same time, as technologies come into vehicles, um, and teens start driving vehicles with these technologies, they're going to start learning with them.
Mhm.
Um, and I know there's a big disparity whether people, parents or the cars purchased for teens or by teens are newer cars with all the systems or really older cars because they're more affordable. And I think there's going to be a big gap there
Mhm.
too, because teens buying their own cars tend to buy the older cars because they're less expensive. And they're going to see these technologies a lot later.
Mhm.
Um, so I could talk for a long time just chatting. Does anybody else have a question or a comment they'd like to make?
Yes, well, thanks for a great presentation. I have a question about, I guess, just your ideas about perception of infotainment system within the cars. And this has been brought up before, like the newer models nowadays having a lot of fancy um, functions built in within those touch screens and could be potentially very distractive. So I'm curious what you think, what kind of impact those sort of things would have on teen drivers specifically.
That is a great question. And my uniform answer is anything that's distracting for teens is not good. So when you have these infotainment systems that, like you said, can do a lot of amazing things, when you combine that with a teen driver who doesn't have the experience yet of driving in certain risky situations or hazardous situations, it's usually not a good mix. They get distracted very easily. They're just learning how to drive, and they're probably just learning how to use that infotainment system at the same time because it goes hand in hand with getting that new car, right? You're learning how to drive the car and you're learning how to use the things inside of the car. And it means they're not paying attention to the road. It means potentially their hands aren't on the wheel. It means a lot of different things that just increase their crash risk.
Yeah, thank you.
So in the chat, we have excellent presentation, Shannon. I'm curious, how long were the teens in the simulator each week?
Great question. So every week, the experiment lasted about 45 to 60 minutes. That's how long they were in the lab. The actual time that they spent driving the simulator in total was probably 15 to 20 minutes. We split up each session into 4 shorter drives, and each shorter drive was like 4 to 5 minutes, and they got breaks in between. And of course, we had the surveys at the very end. Teens often came with their parents, and so we had to deal with a teen and their parent at the very beginning of every session. And so the whole thing took 60 minutes, but they were driving for about 15 to 20 of those minutes.
Thank you. Okay, any other questions? Again, you're welcome to unmute yourself or type in the chat. I don't see anyone typing and I don't see anyone unmuting. So Shannon, I see that you put your contact information, your email at the bottom of the slide. Thank you very much. If anyone thinks of questions or comments or something that they would like to talk to Dr. Roberts about later, there's her contact information. I thought this was really interesting and very intriguing. I think that it really, the automation and levels of automation with teen drivers is going to be a very interesting field in the next few years. So I'm looking forward to the future work you do.
Thank you.
All right. And thank you, everyone. With that, we'll end.